If we are given a quadratic function not yet in vertex form, we can use completing the square to write it in vertex form. How? Well, let's suppose that we have the function f of x equals 2x squared plus 8x plus 6. The first thing I'm going to do to write this in vertex form is, because f of x is kind of clunky and unwieldy to write, I'm going to write y, and I'm going to write y on the right-hand side. So I'll have 2x squared plus 8x plus 6 equals y. Now, my next move is going to look a lot like what I did to complete the square when I was solving an equation. But it's going to be a little bit clunkier because I need to carry this y around. To set myself up for completing the square, I still need one side to be x squared plus bx equals something. But how will I do that now? I will need to get rid of the 6 on this side by subtracting 6 from both sides. But notice these aren't like terms. I get 2x squared plus 8x equals y minus 6. And I have to just keep this y minus 6 because there's nothing else I can do with it. Now I divide both sides by 2, and I get 2x squared divided by 2 is just x squared. 8x divided by 2 is just 4x. Over here, I'm going to keep y minus 6 over 2, for reasons that will become clear as we finish this up. I could mess around with this minus 6, but I'm not gonna. Now this step is exactly like what we did with equations. We're going to add a constant to both sides to complete the square. So we'll have x squared plus 4x plus something equals y minus 6 over 2 plus the same thing. We'll get x plus something squared equals y minus 6 over 2 plus the something. All right. What constant goes here? What constant goes here? Here I have my x squared. I'll split my 4x evenly between these boxes, getting 2x and 2x again. So this box is x by x. This one is x by 2. This one is x by 2. So this box is 2 by 2, which is 4. So the constant 4 is added to both sides. And this is x plus 2 squared. All right. This last step now is completely different from what we did when we were solving equations. Because now we've got all this stuff over here with y. We need to get y back alone. So it looks like I'm going to subtract 4 from both sides. Then I'm going to multiply both sides by 2. That'll give me 2 times x plus 2 squared minus 8. And finally, I'll add 6 to both sides. And my last step is to rewrite with function notation. My function was called f, so I have f of x equals 2x plus 2 squared minus 2. Not that bad. This part and then this part get a little bit messy, but it's not that bad. We do need to be a little bit careful when we multiply both sides by a constant. I'm going to give you one of these to try now. Write the function g of x equals x squared minus 6x plus 5 in vertex form. Pause the video and try this now. Alright, so just For ease of copying, I'm going to write this in terms of y. X squared minus 6x plus 5 equals y. Now I'm going to subtract 5 from both sides. And now I'm going to take a moment to be happy that there's no leading coefficient. So this is in the form x squared minus bx. So this is in the form x squared plus bx equals something. Already, I don't need to do any dividing. What next? Well, now I'm going to say x squared minus 6x plus something equals y minus 5 plus that same thing in order to get x plus or minus something squared is y minus 5 plus my something. So let's see. How do I figure out the constants? I'll have my x squared. I'll distribute my negative 6x evenly. So x by x, x by negative 3, x by negative 3. Negative 3 by negative 3 is positive 9. 9 is the constant that I need. I have x minus 3 here. These like terms I can combine. I've got x minus 3 squared equals y plus 4. Now I need to get y by itself again. Just subtract 4 from both sides. And then rewriting in function notation, my function is named g. I get g of x equals x minus 3 squared minus 4.